arc length, we need to integrate the square root of 1 plus the derivative squared. So the first thing to do is find the derivative here. Since it's natural log, the derivative is going to be 1 over the secant of x. And then because of the chain rule, we need to take the derivative of the secant. So that's secant of x times tangent of x. And then luckily, these secants cancel, leaving us just with tangent. So we'll need to integrate from 0 to pi over 4 the square root of 1 plus the derivative squared, which is going to be 1 plus tangent squared. And then hopefully you recognize 1 plus tangent squared. That, from good old trig class, turns out to be secant squared. 1 plus tangent squared equals secant squared. And then the square and square root will cancel each other out, so what we're going to be integrating is actually just a secant of x. So hopefully you remember the integral for secant of x is the natural log of secant of x plus tangent of x. The way that I remember is the secant of x, if it's the derivative of secant, it's secant times tangent. So the integral has the secant and the tangent, but you just have to remember that it's natural log. And if you ever want to see where this comes from, or recreate it yourself, then take this, write it as a fraction over 1, multiply the numerator and denominator by secant of x plus tangent of x, do some algebra and some trig identities, and eventually you'll end up with this as the integral. It's better though just to remember it. Okay, now we need to evaluate from 0 to pi over 4. So we'll have natural log. So my calculator doesn't have secant. I'm going to have to change this to 1 over cosine. Plus tangent pi over 4. Minus, when you take the natural log of 1 over cosine of 0, and then plus tangent of 0. So tangent of 0 is 0, cosine of 0 is 1, so this part in here I don't even need a calculator for. It's going to be the natural log of 1, which is going to end up to be 0. So if we get anything out of this, it's going to come from this. So we need natural log of 1 divided by cosine pi over 4 plus the tangent of pi over 4. And I need to double check that it's in radians. Yes. So 881 is going to be the final answer, because this is 0, so the final answer is the arc length is 0.881.